Now we're going to start learning how to apply what we've learned about angles, trig functions, and our two special triangles and their relationship to the unit circle. So the unit circle is represented by the equation x squared plus y squared equals r squared. This is a general equation for a circle, where r is the radius of the circle. But as the name implies, the unit circle, the radius equals 1, or 1 unit. So the equation for the unit circle is x squared plus y squared equals r. Notice that we have a circle, and we have 4 coordinates on the circle. Notice that the hypotenuse of the triangle is equal to 1. This is not by accident. Earlier we evaluated our two special triangles, both having a hypotenuse of 1. That's so that we could take those triangles and insert them into our unit circle in order to evaluate the angles. So because the radius is 1, we know that an angle that intercepts the unit circle at 0 degrees has a coordinate of 1, 0. And an angle of 90 degrees intersects the unit circle at coordinates 0, 1. Similarly, at 180 degrees, we have coordinates of negative 1, 0, and at 270 degrees, at the bottom of the y-axis, 270 degrees intersects the unit circle at coordinate 0, negative 1. In our triangle, we have a base with a length of x, and we have a height of y. Therefore, the coordinates x, y is the coordinate where the angle theta intersects the unit circle. So angle theta, where the hypotenuse of the triangle intersects the unit circle, occurs at coordinate x, y. Now let's go back to our trig functions for a moment. The cosine of theta is equal to the adjacent side over the hypotenuse. So I'm looking at angle theta. We have our adjacent side x and our hypotenuse 1. So it equals x over 1. In general terms, it equals x over r, but because the radius is equal to 1, it's x over 1. But x over 1 simplifies to just x. So the cosine of theta equals x. That's important. Why? Because the base of the triangle length x is also equal to the cosine of theta. In other words, the x-coordinate of where angle theta intersects the unit circle is also equal to cosine of theta. You can see that down here at the bottom in blue. I wrote it nice and big because it's so important. The coordinate x is also equal to the cosine of theta. Likewise, if we look at the sine of theta, which equals opposite over hypotenuse, if we look at our triangle, we see angle theta. The opposite side is y over the hypotenuse 1. Y over 1. Again, in general terms, it's y over radius r, but because the radius equals 1 in a unit circle, it's y over 1. And y over 1 simplifies to just y. So the sine of theta equals y. In other words, the coordinate y, where angle theta intersects the unit circle, is equal to the sine of theta. I'll say that again because it's so important. In our blueprint at the bottom, the coordinate y, where angle theta intersects the unit circle, is also equal to the sine of theta. So again, the coordinate xy, where angle theta intersects the unit circle, is equivalent to the coordinate cosine theta, comma, sine theta, where cosine theta equals x and the sine of theta equals y. Now the other trig functions still apply. When we put our special triangle within the unit circle, we can also determine the tangent of an angle, y over x relative to angle theta. Same thing with cosecant, secant, and cotangent. For example, cosine of theta is equal to the hypotenuse 1 over the opposite side, y. So all the trig functions apply. So we've now seen, in general terms, how trig functions and angles and special triangles relate to the unit circle. We're going to evaluate this more on the next slide. Now we're going to evaluate angle theta equals 45 degrees within the unit circle. Now we discussed earlier the 45, 45, 90 triangle. We're specifically going to use that triangle to evaluate angle 45 degrees because the angle we're evaluating in the circle matches the angle of the special triangle. So if we look at the sine of 45 degrees, and here's our angle we're evaluating, 45 degrees, equals the opposite side, square root of 2 over 2, over the hypotenuse 1. Square root of 2 over 2 over 1, which simplifies to square root of 2 over 2. Notice that that is also the y-coordinate for where 45 degrees intersects the unit circle. Here it intersects the unit circle, and here's the y-coordinate. Now the cosine of 45 degrees equals the adjacent side, square root of 2 over 2, over the hypotenuse 1, which simplifies to square root of 2 over 2. And notice that that is the x-coordinate where angle theta equals 45 degrees intersects the unit circle. X-coordinate here. So the cosine of 45 degrees and the sine of 45 degrees intersect the unit circle here and have an x-coordinate of square root of 2 over 2 and a y-coordinate of square root of 2 over 2. Now we could go through and evaluate all the other four trigonometric functions, but we've already done that in the previous video. However, if you'd like to pause your video now and study those again further, please do so. Okay, now we're going to evaluate theta equals 30 degrees. 30 degrees. So this time we're going to use our 30, 60, 90 triangle because it conveniently fits within the unit circle here, and we're going to evaluate this angle here, 30 degrees. So the sine of 30 degrees equals the opposite side, 1/2, over the hypotenuse 1, which of course is just 1/2. So the sine of 30 degrees equals 1/2, which is the y-coordinate where 30 degrees intersects the unit circle. The cosine of theta, when theta equals 30 degrees, is equal to the adjacent side, square root of 3 over 2, over the hypotenuse 1, which of course is just the square root of 3 over 2, which is also the x-coordinate of where 30 degrees intersects the unit circle here. So we've now found the x and y coordinate of where 30 degrees intersects the unit circle using our 30, 60, 90 triangle. You could also go do the same with the other four trigonometric functions, but we've already done that in a previous video. If you'd like to study it again, please go ahead and pause your video now and study this. And the last angle we're going to look at is 60 degrees, which is also from our 30, 60, 90 triangle. Again, theta equals 60 degrees. We're evaluating theta equals 60 degrees here. So the sine of theta, or sine of 60 degrees, equals the opposite side, square root of 3 over 2, over the hypotenuse 1, which equals square root of 3 over 2, which again is our y-coordinate where 60 degrees intersects the unit circle. The cosine of 60 degrees equals the adjacent side, 1/2, over the hypotenuse 1, which of course is 1/2, and is the x-coordinate where 60 degrees intersects the unit circle. Again, you can go through and look at the remaining four functions and pause the video now.